Hi, Lori here to take you through a video lecture on data. So let's get started with that. So data and the tools to analyze data are the building blocks of analytics, and without the data and the tools, we couldn't have analytics. So let's walk our way through that. First of all, let's do a real quick recap on the different types of analytics, and we know that they are descriptive, which describes our data and tells us what happened in the past. We have predictive, which uses that past data and the relationships that it finds in that past data to predict possible outcomes or likely outcomes for the future. And then prescriptive, which is the analytics where we use the model to tell us what is the right answer to do, or what is the right thing to do, or the optimal path for us to take. Let's talk data, which is really the whole reason behind this lecture anyway. So here's the definition of data: numerical facts and figures collected through some type of process. You'll want to know that. Probably put it in your journals. Two sources of data. We have internal data and external data. Internal data is everything that we own. So if at Iroquois I own all of the data concerning the members of my organization, the agencies that we work with, how much business they place with us, information about them as agencies, etc. And that's all generated through my internal processes. So let's say we have a pizza empire, 36 pizza shops. And the question is, what internal data might we have? Well, certainly we're going to know our sales. We're going to know what pizza pies sold the most. We're going to know when we sold them. We're going to know to whom we sold them if they had a delivery. We're going to know what our ingredients cost. We're going to know what suppliers we got them from. We're going to know how much we owe to various people, etc. All of that is internal data. And we have external data, which is from outside our business, and that would be examples, public data and private data. Public data, an example would be the census report or the yellow pages, anything that you can get that's publicly available. The private must be purchased from another company, and that would probably be from a data provider. Amazon is Google, and there are a bunch of other companies, the names of which you will not know, that do this kind of collection of data about individuals and then sell it to people, and you could do that. So for our pizza shop, what might we want to know? Well, we could go to the census and let's say we're trying to decide where to place a new store. We could go to a census and try to find out the demographics of the people in that town or in that area to make sure that we were putting it in a place that our target audience populates. We could also buy information. They have traffic counts and foot counts, etc., on various streets, particularly in major cities. And we could go buy that information and use that to help us decide where to locate our store. Metrics, measurements, and measures. These are really important, and they all begin with M, and they all are very confusing. So, well, they actually begin with me, M-E. So a metric is a unit of measurement that provides a way to objectively quantify performance. And an example of that would be weight or height or temperature, etc. A measurement would be the act of obtaining that data, and that would be either the weighing or the measuring or that sort of thing. And finally, the measure is actually the numerical value. And you'll probably want to put these in your journal too. So an example would be weight, which is the metric, and then that would be what we would be watching if we were on our diet. Our metric would be our weight. Our measurement would be the weighing in on the scales, how we would determine our weight, measured in on the scales, weigh in on the scales, and then our measure is the ounces and pounds that we actually weigh. An IMC example would be customer satisfaction. That's the metric that we're watching. We use surveys and scales to help us measure that, take the measurement of that, and then the actual measure itself would be a score on the Likert scale from 1 to 5. So, for example, Delta does this after every flight, and every encounter that I've had with them. They send me a little one-question survey, and the question is, would you hire the person you just spoke with on the phone, for example, if you were on the phone with them, as a customer service representative if you owned a company that hired, that served customers directly? And I could answer 1 to 5, and that was an example a metric, which is customer satisfaction. The measurement is the survey instrument that they're using to collect my information, and the measure itself was my satisfaction. All right, making some progress. So metrics can be discrete or continuous. Discrete means we can count them. Continuous means they're connected in all ways. So discrete would be the number of students in a class, the number of people in your restaurant, the number of pizzas that you sold, etc. A continuous one would be the number of minutes it took you to prepare the pizza, the number of miles that people had to drive to do their deliveries, that sort of thing. The temperature that the pizza arrived at. Those would all be continuous. Right. Next is the difference between structured and unstructured data. So we're going to deal mostly with structured data, and that means it can be put into a cell in an Excel spreadsheet, basically. And there are 4 types of structured data. There's categorical or nominal, which means names of groups, and the second is ordinal, the third is interval, and the fourth is ratio. Let's dive in to find out more about those 4. So categorical means they can be sorted into categories. So you could use gender, you could use pet type, you could use your geographic location, you could use what's your major, you could use what's your age, and what's your role in the company. All of those would be categorical because we have names for them and you can divide the people into them, but there's really no numerical value associated with them. Ordinal data can be ordered or ranked, but the actual ranking only tells you the order. It doesn't tell you anything more than that. And it tells you that there's a relationship between them. So if I was first in my class or fourth in my class, that tells me where I was in my class. It doesn't tell you how close first and fourth were in your class. Same thing happens with sports teams. Sometimes you'll find a sports team ranked number 1, and they'll be very, very closely pursued by number 2. Other times you'll find number 1 way out ahead. It doesn't change the fact that number 2 is number 2. It just changes the distance. But so the ordinal doesn't measure the distance between those 2 rankings. And finally, college or university rankings would be another example. And then interval data. This is ordinal, but it's constant difference between observations, and it has an arbitrary 0 point. Easiest way to remember this is temperature. So if it is 90 degrees out, it is not twice as warm as 45 degrees. And so the numbers don't have any relationship to each other, except that they are all a specific unit apart from each other. 4 o'clock is not twice as good as 2 o'clock, and researchers typically use survey scales in this way, interval data. And you don't want to say that somebody who gave you a 4 was twice as happy as somebody who gave you a 2 on your Likert scale. What you want to do is say that the person who gave you a 4 was 2 units away from the person who gave you 2. And then finally, ratio data. And this is the most versatile data, and it's a little bit more unusual. And dollars and cents is a perfect example. $2 really is twice as much as $1. So anything in a ratio data, you can actually perform math on it, and it makes sense. Time spent, it could be my pizza took 45 minutes to get here, and that was twice as long as I expected. That's correct. So that's ratio data. Is that a variable or an observation? So these are 2 terms that you're going to run across. A variable is something that is measured, and an observation is the actual result for a single entity. So let's think of, I like to think of columns in my Excel spreadsheet and rows in my spreadsheet. So if I had taken a survey of my students at the beginning of the year and asked them what their favorite snack was, what their age was, what their state was, whether they're from rural or urban, etc., if I'd done all that, those would be my variables. And then each student's response would be my observations. Data reliability and validity. It's very important to make sure that your data is both reliable and valid. Otherwise, it's not useful to you. So reliable means data are accurate and consistent, and and validity means the data correctly measures what you're trying to measure. And here's an example, a nice little visual. On the left-hand side, you can see that the data is reliable. The arrows keep going to the exact same place. So we are predictably getting to the same place, but it's not the right place. It needed to be the bullseye. On the far right, it's unreliable and not valid. So in this particular case, the data is not measuring what we wanted to, and it's not even clustered. Reliable and valid means it's measuring what we want to, which is it's in the bullseye, and that all three arrows are very close together, and that's the reliable part. So hopefully that visual helps you. So now that you have your data, what do you do with it? Well, the very first thing you have to do is learn how to use your data. And when we look at data, usually the best way to go about it is to start with the question that we're trying to answer. Oops, sorry about that. So, what are we trying to learn, and what problem are you trying to address? There are other routes where you simply just look at your data and let your data find a story for you in it, and that's called generally data mining, and happens a lot in marketing, and we'll talk more about that in the marketing section when we cover marketing analytics. But this particular method it uses the idea that we have a plan for what we're trying to find out in our data. Well, once we've got the question we want to ask, or we've identified the problem that we want to solve, we can use all of these different tools to do that. Our descriptive tools are measures of central tendency. That's your mean, your median, your mode. It's like, where does most of your data gather around? And then there's the measure of dispersion, and that's your variance or your standard deviation if you've taken statistics. And that's how far dispersed are your results. Are they clustered right there at the bullseye, or are they all over the place? Crosstabs, oops, sorry about that. Crosstabs is a way of visualizing your data. So you would find your frequency for responses. Let's say we're wondering people's pets, cats or dogs, and then their gender. And then we could look at how many women have cats versus how many women have dogs, how many men have cats versus how many men have dogs. And that's often called a 2x2, and it's just a nice little chart that doesn't need to be 2, though. It can be more than 2. And then we'll learn more about that too. And then visualization is a very important part of descriptive analytics right now, and growing field at the time. Predictive tools, regression, decision trees, etc. And we'll cover a little bit of that, just a smidge in this course. And then prescriptive tools, which are optimization models and simulations to try and identify what all of the different things that might happen in the best route to get to the best result. And we will probably not get to prescriptive tools in this class. So, just want to let you know that I borrowed that image from this source. And that's it for this video. Thanks so much for listening. I hope you're looking forward to working with data and doing more analytics. I know I am.